Welcome back, everyone, to this lecture series on missing data. In part 1, we're going to give you an overview of the options you have when dealing with missing data. And then in part 2, we'll actually show you how to implement these options with Pandas. As you are already aware of, real-world datasets are often going to be missing data for a wide variety of reasons. Unfortunately, many machine learning models and statistical methods cannot work with missing data points. They require some number to be there. So, if that's the case, we need to decide what to do with the missing data. And it's important to note that when you're actually reading in missing values with Pandas, it's going to display them as NaN values, which stands for not a number. It should also be noted that newer versions of Pandas actually have some specialized null Pandas values, such as pd.nat, meaning not a timestamp. And what's nice about this, it just implies the value missing should be of a particular data type, such as a timestamp. So for example, if you read in a bunch of stock ticker data that was the price of a stock with a timestamp associated with it, and for some reason you were missing a timestamp, then the newer versions of Pandas, instead of just replacing it as a standard NaN value, it would replace it as a specialized Pandas NAT value, in order to just display the fact that we know this data is missing, but we also know that it should be some timestamp of some sort. For our use cases, we don't need really to worry about what actual NaN type here. There's a deeper discussion of it inside the Lecture Jupyter Notebook, but really we just need to worry about the 3 options and the 3 method calls to use within Pandas. So the options for dealing with missing data are to simply keep the missing data, remove the missing data, or replace the missing data. And it should also be noted that later on in the feature engineering section, we're going to have a deeper discussion of how to choose these options depending on the situation. However, a really common question I get from students is, hey, I have this particular data set, which options should I choose? And you should know there's never a 100% correct approach that applies to all circumstances. It really depends on the exact situation you encounter and what trade-offs you're willing to make. Each of these options has its pros and its cons. So let's discuss these options in more detail. Let's start with discussing keeping the missing data as is. Basically, if you're missing a data point and it shows up as not a number within Pandas data frame, you just go ahead and leave it be as not a number. So the pros is, this is the easiest to do. You just read in the data and that's it. You're pretty much done. And the other pro is that it does not manipulate or change the true data. Your data set was missing a value, and so whenever you're going to use it, you're going to report that it's missing that value. So what are the cons here? Well, unfortunately, many methods do not support a not a null value. Some machine learning methods do, but many do not. They require some sort of number to be there. And the other con is there's often going to be a reasonable guess for filling in that missing data. A really common situation as well is if a data set or data cell happens to be a true value of 0, sometimes an entry system would just log it as a NaN value. For example, if we're dealing with a grocery store that sells products and maybe they are having a giveaway, so they sold the product at a free price, instead of setting the price at 0, maybe they accidentally set it to just missing a price value, since it was technically no price and they were giving it away for free. So in those kind of situations, it's totally reasonable and actually correct to just set the price to 0. So again, depends on the exact situation of when it makes sense to just keep the missing data versus trying to put in a reasonable guess. So pros with keeping the missing data, very easy to do, doesn't manipulate or change anything. So now let's talk about dropping or removing the missing data. The pro to this one is that it's also relatively easy to do. Pandas makes it really easy to either drop a row that's missing some data or drop an entire column or feature that happens to be missing a lot of data points. And what's also nice about this is with Pandas, you can base this on rules. For example, you could drop a row that's missing 2 data points or 3 data points or 4 data points, etc. So what are the cons here? Well, as soon as you start dropping or removing data from your data set, you have the potential to lose a lot of data or potentially useful information. And what's going to do is that also limits trained models for future data. For example, if your current data set is missing a lot of information on a particular feature or column, let's say it's missing data on the weather for a particular day, so you have a bunch of rows and one of the features is the weather for that particular day. And at your particular time point that you're running these machine learning models, you are missing a lot of data on this particular column. So if you just decide to drop that feature column and then you train your machine learning model, if in the future you actually start collecting that weather data and you don't have it missing all the time, unfortunately, your previous model was not trained on weather data. So now you have to decide, do I just throw all that data away and start retraining on my new data sets where I am keeping track of the weather, or do I just never take weather into consideration? So it limits the trained models for future data. And again, we'll discuss that particular point when we talk about feature engineering in a future section of this course. So just keep that in mind. This one's a little more complicated with that trained model capability. So I want to talk about a little more about dropping a row versus dropping a column or feature. So when should we think about dropping a row? Here we can see we have these countries. Each country is a row, and then we have features of that country, such as the year, population, GDP, and area. And in this particular situation, it probably makes sense to drop a row when a lot of information about that particular row is missing. So we can see here for United States, we only have the year. We're missing population, GDP, area. For this particular case, it wouldn't make sense to drop population, GDP, and area because we have that information for all the other rows except for USA. And in this particular situation, we're going to pretend that we can't just look up population, GDP, and area. So here, it makes sense to drop the row for USA because we're missing a lot of information just for that row. Downside is we are losing what could be a potentially valid data point, but in this case, there's not really any predictive information here because most of it was missing to begin with. So we should probably just remove USA because clearly this data point as a row should be dropped. It doesn't have any useful information in it. It's often a good idea to calculate a percentage of what data is dropped. So for example, here, if we drop United States, we're actually dropping a third of all our data, 33%. That's pretty high because this is such a small data set. But you can imagine if we had 200 countries, it's not a big deal to just drop one of them. Now, let's talk about dropping a feature column. Dropping a feature column is a good choice if every row or most rows are missing that particular value. So now you'll note we have a different situation where we have a lot of information for all the countries, except for some reason, only a few countries have information about that area column. So in this case, it would make sense to drop the column instead of dropping rows United States and Canada. Because USA and Canada, we actually have a lot of information about them. It just so happens to be that we're missing the area. And in conjunction with that, it looks like we're missing the area for multiple countries. So in this kind of simplified case, it would make more sense to drop the area column instead of dropping both USA and Canada rows. Finally, let's talk about the more complex situation where we decide to fill in the missing data. And the pros here is that this has the potential to save a lot of data points for use in training a model. However, what are the cons? This is the hardest to do, and importantly, it's somewhat arbitrary. At the end of the day, if you're filling in missing data with some sort of statistical estimation, you are, in fact, just making up a number. Now, it could be a very reasonable number to make up, given the statistical estimation method you're using, but it does have the potential to lead to false conclusions. So you should always be very careful with the reasoning you're using on filling in that missing data point. So, for example, what if we are filling in missing data where we want to fill with the same value? So here I have a situation for my data set where I have different countries, the year, the population, GDP, and now this other column here is called carriers, and it stands for how many aircraft carriers are present in the country's navy. And in this particular case, what happened is Canada and Mexico don't have any aircraft carriers in their navy for this particular data set. So instead of filling it in with 0, the data set shows as not a number, as in not relevant because there are no aircraft carriers. So it's a really good choice to replace nan if it was just a placeholder for something like 0. So again, with that grocery price example that we talked about earlier, it's a good idea to just say, hey, all these null values, they're actually just place markers or placeholders for 0, since there are no aircraft carriers for that particular country. in this case, this is a great situation to fill in the missing data, and you just say, hey, this was a placeholder for 0. Now, obviously, that takes some domain experience and a little bit of research to make sure that this is a valid choice. Now, there's the other option of filling it in with an interpolated or estimated value. And again, this is kind of one of those harder or more complex decisions to make. So this requires a lot of reasonable assumptions and a lot of domain experience. So this last column represents some percentage of something. And often in datasets, you may try to fill this in, maybe even using interpolation. So you can see here it goes from 25% to 75%. And maybe you're thinking Canada is somewhere in between Mexico and USA. We're actually not defining what percentages here on purpose. So in your data set, it could be a reasonable assumption to say, okay, I think Canada's percentage value of some feature should be between Mexico and USA. So then you could interpolate it between 25 and 75 and say 50% is the correct percentage here. Again, this is a totally made up feature. Percent doesn't really mean anything here. But if you have enough domain experience to say it's not unreasonable to say Canada's percentage is in between Mexico and USA's, you could fill it in with interpolation. Again, this is much harder, requires reasonable assumptions, and at the end of the day, we are technically just making up data for Canada here. Okay, so what we're going to do in part 2 is explore the code syntax in Pandas for dealing with missing values. And later on in the course, when we talk about feature engineering, especially as part of a larger machine learning project, we're going to have a deeper discussion on trying to decide between keeping, removing, and replacing options for a real data set. So just keep that in mind. We're really going to talk about the mechanics of how to do these options with Pandas. Later on, we'll actually show you a real-world discussion on what option we should choose. We're going to head straight to the Jupyter Notebook and show you how to either keep missing data, replace missing data, or drop missing data, all with Pandas. Let's head to that Jupyter Notebook. Okay, here we are in the Jupyter Notebook. I've already imported NumPy as NP and Pandas as PD. As a quick note, with the version of Pandas that we're using for this course environment, we're going to use np.nan to display a null value, essentially saying this is not a number, we don't know what it is, it's missing. But newer versions of Pandas will have pd.na, which is a new Pandas value, and there's a little bit of description inside the lecture notebook with a link to the GitHub issue. This is probably going to be in the future the way they indicate missing data. And there's also specialized versions like NAT to symbolize that the value that is missing should be a timestamp of some sort. But for right now, we're really just going to focus on np.nan, since when we read in data, that's the way it's going to be displayed. So the second thing I want to focus on is that typical comparisons should be avoided with missing values. And there's 2 great links inside your lecture notebook, which give a little more explanation than what we're going to show here. But essentially, when I mean that typical comparisons should be avoided, if you say np.nan and check for equality with np.nan, often beginners will think that this should be true. But in reality, it's actually false. And the general logic here is that since you don't know truly what this value is, it should be missing, and you also don't know what this value is, it's missing, there's no way you can actually tell if these 2 missing values are going to be equal to each other. So it says they are false. However, if you are checking for some value to be nan or not, you have to say np.nan is np.nan, and then that will return true. So if you have some variable that for some reason is missing, you should be using my variable is np.nan to check whether or not it's actually a missing value. Don't actually use equality here for the reasons stated earlier. Okay, so next, let's go ahead and read in a data set that has some missing values. I'll say df is equal to pd.readcsv, and this data set, it's in the Pandas folder. It's simply called moviescores.csv. And if we check out this data frame, notice we have some information. We have actors here, first name, last name. So first name of actor, Tom Hanks, the age of that actor, the sex of that actor. And then we went ahead and did a survey here. So essentially, people were asked to score their opinions of actors from a 1 to 10 scale before and after watching one of their movies. However, some data is missing. So here we have Tom Hanks, 63, male, and the pre-movie score for this survey was 8. And then after watching a Tom Hanks movie, they decided to score him 10. You'll notice this second row at index 1 is missing all the values. And then you'll notice Hugh Jackman, it looks like for this particular survey, we didn't actually have a pre-movie score or post-movie score. So we didn't actually show any movies here. And then Oprah Winfrey and Emma Stone, you'll see that those are fully informed. Okay, so let's go ahead and show you how to check and select for null values. One way to do this is by saying df is null. And what this method does is it simply returns a Boolean, true or false, if you have a null value. So you'll notice true for every item in row 1, where they were all null values. And then Hugh Jackman, row 2, we have true because he didn't have a pre-movie score or post-movie score. If you want to check for the opposite, you can say df not null. Run that, and then you'll get essentially the opposite of that. It's going to give you false if it is a null value, and true if it's not a null value. Okay, so as you can imagine, we can start using actual columns and this not null or is null method calls to select rows based off whether or not it's missing that value. So for example, let's go ahead and check out all the actors where we're not missing their pre-movie score. So that's going to be Tom Hanks, Oprah Winfrey, and Emma Stone. What we can do here is say df and then select that column, the pre-movie score, and then say not null. And now we have Booleans associated with each row. So I know that I have a pre-movie score for row 0, 3, and 4, which then I simply pass this in, just as we've done before with conditional filtering. And then I only get back the rows where I have a pre-movie score. So you can use these not null and is null conditional filtering to only select columns where certain features are present. Okay, so another example is, let's say I was only looking for an actor where the pre-movie score was missing and then their sex was also not null. What I could do here is just combine these. So say pre-movie score is null. Recall it's Hugh Jackman. So if I just pass this in, I say pre-movie score is null, that's Hugh Jackman, and it's also the row that's missing everything. So there's 2 here that are returned. So this row that's missing everything, and then Hugh Jackman. And let's say I want to add in another condition, maybe where we actually know the first name. So I don't have to worry about these rows where I don't even know the actor's name. I can combine conditions just as before. I'm going to zoom out just a little bit so we can see this. We just wrap this condition in parentheses and then say and then parentheses here I'll say where first name is not null. So just as before, this is conditional filtering, except now we're using method calls on these columns, and this is essentially asking me or asking Pandas to return where is the pre-movie score null and where I also know the first name. So the first name is not null. And so when you run that, you only get back Hugh Jackman, which makes sense. Okay, so now that we're familiar with the is null and not null methods, as well as how to do conditional filtering based off if something is null or not null, let's talk about the 3 options we had, which were to keep the data, drop the data, or fill the data. So keep the data, that one's really easy. You just say df, read in the data, and then if it's missing, you just go ahead and keep it in. Okay, so keep the data, pretty much done with that one. You just read in the data set, keep any missing values, and then you're done. So let's move on to dropping the data. And there is a drop NA call, and I would highly recommend that you call help on df drop NA. And then it's actually going to show you some really nice examples here of how it works, as well as the important parameters. And the important parameters are really axes, essentially saying, are you going to drop based off rows or based off columns? How are you going to drop it if you have any cells missing or any values missing or all those values missing? And then also the threshold, which is going to require that many non-null values. And then you also have the subset argument, which is going to allow you to only consider certain columns. So let's kind of build up on these different parameters. And what's nice here is they're actually showing you an example here of this data frame, as well as how to quickly build in that data frame. And what we're going to do here is say, take my data frame, and then I'm just going to say drop NA. And if you just say drop NA, essentially what it's going to do is it's going to drop any rows that have any missing values. So you run that and you get rid of that row that had all those missing values, as well as Hugh Jackman, where he didn't have those movie scores. But let's imagine we only wanted to drop that row that was missing all those values. What I can then do is use this threshold argument. And again, the threshold, sometimes it's a little tricky to understand, but all it's saying is I require that many non-null or non-NA values. So if I come back here and say threshold is 1, that basically says go ahead and drop any rows that contain null values unless they have at least one non-null value, which that means when I run this, I see Hugh Jackman again, even though he's missing his pre-movie score and post-movie score, he has at least one non-null value, such as his name. And I can keep raising this. I can say 4 here. And you notice Hugh Jackman still shows up because we have his first name, last name, age, and sex. But if I raise this to 5, he gets dropped because he doesn't have at least 5 non-null values. Okay. So that's a way to kind of distinguish dropping something that's missing all the values versus we have at least some information on them. Nice way to essentially remove rows that are just missing everything. Now let's also talk about the axes argument. If I say df drop NA and I say axis equal to 1, you'll notice by default, if I do shift tab here, axis is equal to 0, meaning it's focused on the rows. If I say axis equal to 1, it drops everything. So why is that? Well, now it's considering based off columns. So it's essentially saying in our original data frame, here we have basically values where we have columns that are missing values. And you'll notice that every single column has at least one instance of a missing value. First name has a missing value in the column, last name, etc. And it's really because of this row 1. So if I say axis equal to 1, instead of dropping rows, it's going to say, okay, drop columns that are missing any values. So that's all the columns. All the columns have missing values here. So typically when we're dropping things based off null values, especially with the way we organize our data, where rows are data points and columns are feature, we're just going to leave default axis is equal to 0 because that's really typically the way we're thinking about this. Okay. So as you can imagine, you can use a threshold argument to essentially filter out based off any conditions you want. And the last important argument to show you is the subset argument, which is basically only going to consider certain columns. So define in which columns to look for missing values. Here they're using subset. So let's go ahead and do that. We see df here. And then what we can say is df drop NA. That removes everything that's missing any values based off the rows. But if I say subset and we pass in a list of columns to consider, such as last name, and we run that, you'll notice Hugh Jackman now shows up instead of being dropped as before. So if I say df just drop NA, it drops Hugh Jackman. But if I say subset, it's basically only going to consider the last name column. And there was only one row that was missing the last name. That was this number 1 row. So you can use combinations of subset and threshold to filter out based off whatever columns you're concerned with that are missing values. Okay. So we now know how to drop values as well as how to set conditions for what values should be dropped. But now let's move on to actually filling in the data. And this is kind of the hardest one to really consider because you have to have a reasonable choice here. So if I say df, I can call fill NA. And again, I would encourage you to call help.fillNA and check out the documentation here where it's showing you examples of how to fill NA. But something to note here is that right off the bat, you could just say df fill NA and then just provide a single value that would fill in every single missing point. So I'm just going to provide a string here saying new value exclamation mark. So note we have first name, age, and so on, pre-movie score. And if I just say fill NA to a new value, it automatically fills in this string to wherever we had stuff that was missing. Now typically this is not what you're going to do because now I'm replacing strings where something should have been probably a numeric like 63 or 51. And so what Pandas ends up doing is if you start filling in strings for columns that should have been numeric, it's going to start making this 63 into a string instead of a floating point value or integer value. So while this is possible of saying fill NA, typically we don't just say one value. Instead, we grab the column we're interested in filling. So, for example, if I wanted to select pre-movie score and wherever that's missing a value, go ahead and fill it in with zeros, I would say df pre-movie score and then call fill NA here with 0. And so now you'll notice that there's zeros here instead. And if I wanted to make this change permanent, all I would need to do is assign this change. Take in the current pre-movie score. If there's a missing value, fill it with 0, and then that's my new column. Now, I'm not going to run this to show you a couple more examples, but hopefully you get the idea that you can do this typically at a level. So for example, if I didn't know the sex, but maybe I assumed anyone with missing sex was male, I could say fill NA with the string M. And one of the most common questions I get then from students is, I don't want to fill in by just some arbitrary value like 0. I actually want to fill in based off a function, like the mean. Well, that's actually quite easy to do. So if we take a look at pre-movie score again, notice I didn't run that cell, so I still have the null values. You can simply read in the data frame CSV file again if you accidentally ran that. But let's say I want to fill in these null values with the average pre-movie score. Well, what do we do here? We can simply say df pre-movie score dot mean. And what's nice about dot mean is it's going to give you the average based off the existing values. So it's only looking at 6, 7, and 8. And the average of these three should kind of obviously be the center value, 7. So that's the mean value. And so what we can do is say df pre-movie score dot mean and then say dot fill NA with the mean value. And when you run that, you'll notice that these 2 points that were missing are now filled with the average value. And sometimes if you have a pure numeric column, what you can do is say df fill NA with df mean, open close parentheses, and that will attempt to automatically fill everything with the averages. Now, does this make sense sometimes? Maybe. It probably makes sense for something like pre-movie score, where you just assume that people have some sort of average feeling towards an actor, but it probably doesn't make sense to start doing things like fill in with the average age. What is nice about this method of just calling it on the entire data frame is for things that don't have an average value, there's no average value for the first name, it just went ahead and kept it as null values. So it's kind of like a quick and dirty way to fill in things. And finally, the last thing we'll show you for filling in missing values is with the interpolate method for interpolation. Now, we're typically not going to actually use something as direct as this, but I do want to show you that this method exists. We'll show you kind of some more sophisticated ways of doing this within the feature engineering section. But I'm just going to copy and paste this dictionary from the lecture notebook and then turn this into a series by saying series is equal to pd.series, airline ticks. I run that and I get my series. So as I mentioned before, sometimes you want to interpolate. Is this a good situation for interpolation? Probably, because I can see these are airline ticket prices where economy is $30, economy plus is at $50. I'm missing the business value price class, and then there's first class at $100. So it might make sense to try to interpolate this, assuming it's already in the correct order. Again, that's kind of a big assumption here, but I could interpolate missing values. And what it does is it just does a linear interpolation from the point above and the point below. So it's going to fill this in with a linear interpolation between 50 and 100, which is essentially the average between 150, which is going to be 75. And for that, you simply say interpolate. And then it fills it in with the interpolation. Again, we're really not going to do this too often because you have to do a lot of assumptions here as far as the ordering of your data, but technically you could sort by maybe another column and then start the interpolation process that way. There's a link to the full docs on the method. You can also just kind of do Shift Tab here to explore the documentation inside your Jupyter Notebook. But as I mentioned, we're going to show you some more sophisticated ways of filling in missing data when we talk about feature engineering, essentially using values from other feature columns to fill in the data. All you need to understand from this lecture is that you have a couple of method calls that you should know. So after this lecture, the main things to take away is the fact that you shouldn't be doing comparisons on null values with equality, instead used is. And then there is the isNull method, as well as the notNull method available to you. And then finally, there is Dropna available to you, as well as, if we scroll down here, the Fillna method. Thanks, and I'll see you at the next lecture.